Yeah.
See, I threw this one on here just as a review question. Just try it with your partner. I'm just saying this because I started the recording, wanted it to show up on the recording. But I'm going to go ahead and graph it while you guys are, and we'll just all make sure that we got the same thing. And when it says show the orientation, what does that mean you have to put? Arrows, just to show the direction that it's going. That's what the orientation means.
I like it when it's easy. I don't like it when it's hard.
Well, everybody likes things when it's easy. That is a good assumption. Can you guys end the other conversation that you're having though? I mean, I kind of don't. I noticed this is squared, so I know there's going to be a curve kind of to it. But I just plotted these points and connected them, to be real honest with you. I just played connect the dots. Oh, because we're only going, our parameter is only going from -2 to 1. So like I don't want to go any further and end up here. If the interval was larger, then you would get those points. But we just, oh no, we just kind of stop where it tells us to. So you get like a piece of a parabola. All right, and then the other thing is eliminate the parameter t. I should just say t. Eliminate t. Which one of these is easier to solve for t? The x one, because there's not a squared. If you square root, then you deal with a plus minus. Things get complicated. So we're going to just do some algebra. We're going to add over the 3, and then divide by 2. And then we're going to take that and do what with it? Yeah, plug it in to the other equation. This is solving systems of equations, if you remember that from Algebra 1, which you probably don't because it was so long ago. It's called substitution. All right, anyway, it's going to be 3 times all of that stuff squared. Again, I'm a real big fan of leave it blank and then just go fill it up. And then you have y in terms of x, and that is not parametric. Do you remember what we call them if they're just regular old equations? Rectangular. Good job. Have you heard that before? Oh, you just have really, I'm just always impressed by you. I say something once and everyone remembers it. It's great. All right, number 2, irregular, rectangular. All right, write parametric equations for this rectangular equation so that the curve goes through the point 3, 0 for when your parameter, 3, 1 when your parameter is 0. Geez, I need a break. Okay. Does that feel like an initial condition? Because that's what it is. Okay, just you have an initial condition for x and an initial condition for y. Good news is you really only need to worry about the x because then the y will sort of just happen. So we want parametric equations, an x equals and a y equals. So we want t to be in there, and this one is going to be t plus 3. I'm telling you that's the answer, but I want you to think about how I got that. Where did that come from and how did I get that? Because if I plug in 0, I want to get 3, okay? And then we're going to take that t plus 3 and just plug it in for x in our equation. So it's going to be y equals 2 times all of that, minus 5. And I do want us to, distribute and combine like terms so that we can verify that we get the 1 part of our initial condition. If you distribute that 2, you're going to get 2t plus 6 minus 5, which would be plus 1. Now, if you plug in 0 for t, do you get 1? Yes. Okay, so those are our parametric equations. Basically a whole big bunch of algebra. All right. Kind of review of last time. Now we're going to move forward and start doing derivatives with these. Okay. So if you have x equals something in terms of t and y equals something in terms of t, the slope dy dx, this is going to look awful, but it's really not that scary. Okay. Dy dx equals dy dt over dx dt. Does that make sense? Derivative of y over derivative of x. I'll show you the second derivative in a second. Let's answer these real quick. Horizontal tangent line would be when your slope is what? 0. That would be when your numerator is 0. So that's when dy dt equals 0. Vertical tangent line is undefined. Vertical means undefined. That's when your denominator is 0. So that's when dx dt is 0. Is everyone following me there? This is 0 and this is undefined. Okay. And that always goes well. That's fine. Second derivative is where it's like a little extra. We're going to put our 2's in here for our second derivative. You start out by doing the derivative of what you had. So we're going to do the derivative, and d dt is instructions that mean take a derivative of dy dx. So you're going to do the derivative of this over dx dt. You have to divide by dx dt again. Oh, and I'm glad we had this conversation during the warm-up. That's what makes it like per day, or per day squared. Do you get what I'm saying? Or like usually it's feet per second, like feet. What makes that be the per second? We do this one last, not because it's the hardest problem, but because it involves some trig, and I know that's like a shaky area for you guys. So I don't want to start out with one that's going to terrify everybody. So we're going to start out with one that's a little bit more like friendly, so to speak. Okay. So we're given our parametric equations, find dy dx. So we're going to do derivative of y, which would be what? 1/2 t, good. That's it, right? 1/2 t. All right, fraction bar, and then you're going to do derivative of x. I told you to just memorize. What's the derivative of square root? It's 1/2 square root. Now, we have to do the derivative of that mess to get our second derivative, so I do want to clean it up a little bit. I'm going to multiply by that. Oh, t, thank you. Sorry, that's just a, my hand is so used to writing x. Apologize. So I am going to clean this up a little bit because I don't want to take the derivative of it as it looks right now. So I'm going to multiply by 2 square root of t. Why on earth would I do that? Like, how does that benefit me? Yeah, this is going to go away. The denominator is just 1, so I don't even really need it. Another convenient thing that happens is the 1/2 times 2. You make that, well, you can write a 1 if you want to. I'm going to just not write anything. And now let's put these together. This is really t to the first, and this is t to the power 1/2. So if I put them together, it's 1 1/2, which is 3/2. Good job. We had to fight through the fractions there. But if you got through all the fractions in Euler's method, this is like cake, right? So second derivative, you're going to do the derivative of that. So you would bring the 3/2 down, and your exponent would drop to what? 1/2. And you divide by dx dt again, which is 1/2 square root of t. And we're going to do the same thing again to clean it up, just because I feel like you guys can handle it. So we're going to multiply by 2 square root of t. Oops, I don't know why I did that. And what happens is these cancel out, which is, the whole point. And in the numerator, the 2's cancel, but we still have a 3 there. So it's going to be 3, and then the same thing's going to happen. This is t to the, oh no, I guess it's not quite the same. This is t to the 1/2, and then this is t to the 1/2. So 1/2 and 1/2 is 1, so like just t. So that actually turned out kind of nice. Cool. Find the slope and concavity at the point 2, 3. This is in terms of t, though. This is x, and this is y. What on earth is t? That's the first thing that you have to figure out. So you're going to look and see which one of these equations you think is easier to use, because it actually doesn't matter. In this case, I think x is a little bit easier to use. You're welcome to agree or disagree. But if x is 2, what is t going to be? 4. Square root of 4 gives you 2. And then you can kind of check. If you plug in 4 for t in this one, do you get y being 3? Let's just check it. It'll only take a second. 4 squared, 16. A fourth of that, 4 minus 1. Do you see how it came out to 3? All right, so you can just check. All right, so let's do our slope first. That's our first derivative, which is this right here. We're going to plug in 4. Let's figure out what's going on here. This is a square root that is to the third power. So it's going to be a square root to the third power, and we're going to plug in 4 and see what we get. So square root of 4, 2. 2 cubed is 8. The whole point of figuring that out is the graph increasing at that point, or is the graph decreasing at that point? Why increasing? And if you say it, they won't give it to you. If you say the graph, they won't. I know it sounds like I'm being so hateful. It's because, who's your source that you're citing? First derivative. It's the first derivative test. Remember your sticky note? First derivative is dy dx is positive there. It's okay. You'll get to redeem yourself because now we're going to do concavity. We're going to plug 4 into our second derivative, which would give us 12, which is also positive. Now, what does concavity tell you? Because that's not increasing, decreasing. Concave up. Good. So concave up, since that's positive, and your reason would be because second derivative is positive at that point. Cool. Good job. And then we reviewed that. All right. D is asking for equation of a tangent line. What 2 things do you need for an equation? Yeah. They just handed us the point, and then we need the slope. I made it the same point we just did to make things simple. At this point, t is 4. Cool. And we already plugged 4 in and got our slope, and it was 8. I did that on purpose because we already did it. And then you just put it together to write your equation. It'll be y minus 3 equals 8, x minus 2. So when they give you a point, though, you need to find t at that point. You need to figure out what the parameter is at that point and then plug that in. So there's like that extra step. We'll do this one, and then I'll give you a little brain break. This is going well, though, I feel. Do you feel like it's going well? Like we're vibing, right? So use these parametric equations. Our interval is from 0 to 2 pi. All right, first derivative. We're going to do dy dt over dx dt. So what is our derivative of cosine? All right, so negative sine over dx dt. So derivative of sine. Okay, now I'm going to ask you to remember some stuff here. Do you know what sine over cosine? Perfect. So this is negative tangent. Good job. If you can simplify the first derivative, it makes getting the second derivative a whole lot easier. So now we're going to do the derivative of that and then divide by what? We'll divide by dx dt again. Thank you. So he's already down there. This is for you. Did you like request to go, or are you supposed to be volunteering?
I said I would be.
Okay. We're gonna file this. Okay. That's what I call it. We're gonna file that. Okay. So we're gonna do the derivative of this. It will be negative. Okay. Does anyone remember the derivative of tangent? Psst is what we put here. Let me write it up for everybody. Psst. It means it's positive, but ours is actually negative. Okay. You cover up the one you have, which is tangent, and your answer is secant squared. Good job. Over cosine t. I'm not going to clean that up. That's fine. Because we would never have to do a third derivative of that. So you have to divide by dx dt again. Okay. And we already did it right there, so I didn't talk us through it again. All right, and then we'll do this one and we'll do a little break. At what point is there a vertical tangent line? If you forgot already, you can flip it over, but is that where dy dt equals 0 or where dx dt equals? Dx dt equals 0. I'm just writing that for extra emphasis. When would you do dy dt equals 0? Horizontal. Good job. Horizontal. All right, so our dx dt was cosine. And now we got to think about our unit circle. Cosine is which part of the coordinate point? It's the x. We need to find a place on our unit circle, and it's in between 0 and 2 pi, where our x coordinate is 0. Is it this one? No. Is it this one? Yes. All right. Is that the only one? No. Is it this one? No. Is it this one? Yeah, see how x is 0 there? So it's pi over 2, which is this one. And then what is the one at the bottom? So let's talk about that, though, because negative pi over 2 is not wrong, but is it on this interval that they gave? No. And you have to be really careful about that with the unit circle, because you can rotate around and around and around, or you can rotate backwards. So you have to be really careful with the interval that they give you. Yeah, I just felt like this one on the front was just a little tougher, and I didn't want to start with the hardest problem.
Wasn't it asking for like the points on it?
Oh, you're right, technically. I found the parameter, but if you want the actual points, we have to take t and plug it back in to get x and y. So that's a good point. Let's do that real quick. And I already drew the unit circle, so don't groan. It's already, and I drew it. All right. So look at x. It says sine of t. So for pi over 2, sine, which is right here, what is sine? What is 1, comma, and then we're going to plug pi over 2 in for y, which is just cosine of pi over 2. So 0. So 1 comma 0. And then why is there a second one? Why are there two answers? It's 2 values of t, which is down here. I'm not going to slide the paper up and down. Your x coordinate, that was sine of t. Sine would be -1. Cosine would be 0. Which actually, let me show you what that would look like, because I think you guys would be interested in it. Let me show you. Will you humor me? Well, and it'll be interesting for you to be able to type these in. Okay, so here's how you type a parametric equation on the calculator. I'm going to put parentheses, and then what is our x? It's just sine t, right? Comma, and then y was cosine t. And then they usually give you a little place to put in your interval. And what was our interval? 0 to 2 pi. So here's what that looks like. Isn't that cool? Is it exactly a unit circle? I don't think it's exactly at 1, but yes. So at the point, oh no, it is, because at the point 1, 0 and -1, 0, you would have vertical tangent lines. Do you see that? Cool. So it was a unit circle. Neat. Neat. It's neat. All right, go flip over. I'll show you what this one looks like too once we finish it. All right, first thing we're going to do is find both of our derivatives. So right underneath x, I'm going to put dx dt. So we'll do this nice and slow because this one's a little bit more complicated, all right? Derivative of 2t is just 2 minus, now, if it was like 7 sine t, the derivative would be 7 cosine t. Remember that pi is just a number. So your derivative of pi sine t is just pi cosine t. Remember, pi is just a number. It's just a coefficient. And then I'm going to do dy dt right here. It kind of didn't line up, but that's okay. All right, derivative of just plain 2. 0, that's nothing. So I'm going to just cover it up. So we're going to have negative pi cosine t. But what's your derivative of cosine? So, okay, so the negatives are going to cancel, and we get pi sine t. Good job. You followed me there. Nice. So letter A, at what point or points is there a horizontal tangent line? Horizontal means a 0 slope. Which one of these are we going to set equal to 0? Dy dt. So this pi sine t gets set equal to 0. You would divide both sides by pi, but 0 divided by anything is just 0. And here, I'll draw another unit circle for you. So we want points on our unit circle where sine is 0. Sine is the y value. So that would be right here. And oh, wait, what's our interval? Got to always be careful. Okay, so negative pi would mean you went this way. Positive pi means you went this way. So we actually only get one answer there, which is 0 pi. And I recommend putting the pi next to that. Don't just put 0 because then it confuses you with these zeros. It's no pi. Now, that's not the point. I'm not going to mess it up this time. Or I didn't mess up. I just forgot to. What? Yeah, t equals 0. We set sine t equal to 0. Sine is the y value on your unit circle, so that's happening at 0 pi. That's the location where, like, the amount of rotation where that happens. So we're going to plug 0 pi back into our equations. So if you plug 0 in for t right here, that would just be 0. And then sine of 0 is 0. All right, so 0. And then to get your y coordinate, you're going to plug it back into your y equation. So cosine of 0 pi is not 0. Cosine would be 1. So like this whole part is just 1. So it would be 2 minus 1 pi, which would be about how much? If you think of pi as like about 3, I mean, I know it's 3.14, but if you think of it as about 3, that would be like roughly -1. Okay. Let me finish this one. I'll type it in so you can see a visual of it. So this says write both tangent line equations. So we're going to have 2 of them at the point 0, 2. So I'm going to go ahead and write m equals m equals. The problem just told me that there's going to be 2 of them. But the unfortunate thing is you need t. Like you need your parameter. So which one of these equations will it be easier for us to use to solve for t? It is dy. I know that one looks kind of complicated, but why would we not use x? There's 2 t's in it, so that makes it more complicated. All right, so what is our y value at our point? 2. So we're going to say 2 equals all of that. So 2 equals that stuff. I'm not going to read it all because that's annoying. And then we're going to just have to solve it. We're going to make it through, though. It's going to be okay. What would you do first, algebra-wise? Yeah, you would subtract 2, and this is very convenient because 2 minus 2 is 0. So we kind of lucked out there. And then you would divide by negative pi, but 0 divided by anything is 0. And so we're looking for places on our unit circle where cosine is 0. Cosine is the x coordinate, so we kind of just did this on the other side of the paper. Yep, it would be pi over 2 and 3 pi over 2. You get a lot of repetition with the unit circle because there's, yes, thank you. Because of our interval is from negative pi to positive pi. Thank you. You guys keep saving me. Yeah. I even drew arrows right there. But do you know how sometimes when you write the same thing over and over and over again, your hand just kind of like acts independently? I'm just so used to it. Yes, negative pi over 2. Now to get our slopes, we're going to plug into our derivative, which is going to be dy dt over dx dt. I'm not going to write this over this. We have them both there. We can see it. All right, so let's try and plug in pi over 2. Sine of pi over 2 is 1. Times pi is pi. Right? So that's our numerator. dx dt is the denominator. So let's plug in pi over 2. Cosine of pi over 2 is 0. So this whole part is gone. 2 minus 0 is 2. So weirdly, that came out to pi over 2. Again, just trust the process. You get a lot of repetition. All right, if we plug in negative pi over 2, sine of negative pi over 2 is -1 times pi would be negative pi. And then this one, again, that's going to be 0. 2 minus 0 is 2. So we got a positive pi over 2 and a negative pi over 2. Unfortunately, we now still have to write the answers. This is your point. These are your slopes. You get 2 answers. So y minus, close, 2 equals pi over 2 parenthesis x minus 0. Or I guess you could just write x. I just like to be thorough and write the whole thing. And then the other one's going to be literally the exact same thing except negative pi over 2. And again, I'd like for you to not stop listening to me. Everybody stay focused because the visual seriously does help a lot. I want you to see what this looks like typed in. And also it's just cool. It is just cool. So just sit back and watch. That's all I'm asking you to do. All right. So when I come over here, the way that I type in my parametric equations is I'm going to almost make it like an ordered pair. So I'm going to have parentheses, and then what was my x equation? 2t minus positive, oh geez, that's a lot. All right, so 2t, I can feel you guys not listening. Is it sine t? Good, okay, not parentheses, comma, and then the other one is 2 minus pi cosine t. Thank you. All right, and then our interval is negative pi to positive pi. So it looks like this. Isn't that cool? It's neat. It's neat. Why does it stop? Yeah, our interval ran out. Now let me put in the tangent lines. It was y minus 2 equals 2. I'm just going to write x. Do you see how that's a tangent line there? And then I'm going to copy paste it. Nope, don't do that to me. And change the pi over 2 to negative pi over 2. So do you see why there's two answers there at that point? Isn't that cool? It's cool. It's neat. I told you it was a cool picture. Told you it was cool.
Yeah, man.
All right, so you have 25 minutes to do your delta math. Let's focus and get it done. What did you say about physics? Oh, did you? Is this help you understand something about physics? Is that what you're saying?
No, I was just saying, that reminds me, like, you make arguments and stuff.
Yeah.
It just kind of reminds me.
I like that. It's like a little curly Q. Well, also, so heads up, I like to do a lot of trig when we do parametric equations because a polar, which is the next thing we're going to do, a polar equation essentially is a parametric equation with trig in it. So I like to I always love to do that. Like I preview something and then when we get there, it's kind of like, hey, we already did that. So it seems less scary. So I made a decision, and we kind of made the decision together. I'm going to give you this piece of paper. If we miss through Wednesday, so if we miss class Monday and then no school Tuesday, and then we miss again Wednesday, that's where the expectation comes in to do this. Does that make sense?
Yeah.
And you will just watch a video, and I'm picking this lesson because it's very short. It's an easy thing for you to knock out at home. I'm going to give you a formula, and you're going to plug into it.
Yeah.
Yeah, so just tuck this away somewhere. And if we miss through Wednesday, then I'm going to expect you to do it. Also, your test corrections are still due Monday at 4 o'clock.
Oh,
Okay? Monday at 4 o'clock.
yeah. Spells. Over
That works, man.
there. You sure? What do you mean, bro?
So are you saying that?
No,
Well, I'll pick up your desk. You'll go back there.
No.
Well,
You sure I
we're
should
doing
recycle
everything
this?
right now.
I'm on the recycling committee, bro.
No, are you sure I should recycle this?
Yeah.
Are you gonna use it?
Logan,
No.
if it was Chinese.
Hey, Miss Cole, should I recycle this?
You know, when they brought in the recycle bin, they said it's the teacher's responsibility to go empty it. Now, I don't have any intention of doing that, so you can put it in whatever receptacle you feel like.
Me, Mike, Mo, Ketchup, Tiger, Thigh, So.
All right, just throw it away and go sit down and do your work.
Okay, I've been recycling. Trust me.
No, she said throw it away.
I'm picking it up tomorrow. I'm on the recycling.
Oh, wait, can you do my recycle bin?
I will.
Perfect, then we can recycle.
Yeah.
Oh, I never hit stop.